You know, for a rookie home gamer with a rinky-dink little workshop in a small upper apartment, I actually have a lot going on all the time. I actually have too much going on so that I can't even do it all. And so I end up with like stuff sort of building up in like basically like on deck that I just don't have time to get to because I just have to work too much at my actual like job. Um, so like here's a lightsaber sort of on deck circle or table. Um, Different lightsaber projects, Graflexes in different stages of being built. Just all my lightsaber, not nearly all my lightsaber projects. Everywhere you look, there's stuff going on. I got every drawer in this freaking apartment is lightsabers, but over here is like an on deck area for just like little LED ornaments and alarm clocks and random whatever. Some cool heat sinks and whatnot. But yeah, so I end up with, this stuff that's kind of just on standby that I can't get to. And I have these little staging areas or on deck circles all over the place. Man, that light is too much. Let me kill that. Okay, so like over here, well, maybe that light was actually needed. But anyway, this is what I'm going to be doing for this project. This is just one of my little sort of to help me contain the mess. I keep, stuff. These are projects in various stages or whatever. It mainly consists of, this is like my little tickle trunk of stuff that I have going on, right? Mostly you find this in it, lightsaber guts in various, degrees of being installed or hooked up or whatever, but a lot of those, and just random, just basically electronic bits. And so I'm gonna take all this out. What do I got in there? Looks like some kits. There's a clock kit, random stuff, battery packs, connectors, displays. So, are empty? Yeah. So anyway, the idea for this is going to be to dress this up and, make it an LED ornament at the same time as it is storage for electronic guts mess. So yeah, that's what we're doing. And it's going to be basically like the last project, using kind of like Big Clive's sort of light sensing circuit as the base of it, but we're going to be taking it up a couple notches this time and just doing it a little different altogether. These things actually have their uses for oddball stuff. This is the power cord. See how big to make the hole. Yep, that'll do her. So to build the electronics in it, I'm going to give it a false bottom. Found a sheet of plexiglass at work that's going to be perfect. It's super rigid. It's kind of hilarious because I was going to countersink some holes in it anyway, and they're just about perfectly spaced out. But one downside is it makes it super, super annoying to size this piece and cut it. Because I have to cut it to, like, size the space the legs out for this false bottom. But it's going to be a really nice material, super rigid, and it's a thinner piece, so it's not going to block any light. So yeah, I'm going to go ahead and get that to size, and then get her all fitted for the legs and whatnot. Get the structural stuff done. I could have waited to get out to the shop and done this properly on like a bandsaw or a table saw or even like the miter saw, just like chop saw, or any number of ways. But I don't want to wait, and plus, on principle, it just kind of makes sense for what this is. It's just a quick and dirty project. And like all the guys that I watch that I look up to on YouTube, they're always about that. Like, you know, saying, you know, like Ave and Big Clive and stuff, you don't need fancy tools and books and education, all this shit. All you really got to do is just start doing it. I mean, really, all you need is the proper balls to brains ratio, and you're good. So I'm just gonna do this ghetto style. Oh yeah, that's gonna work. $3 at the dollar store. Neil, what are you doing? Okay. So little pro tip. Pro tip. Pro. Yeah, fucking right. But anyway, little tip. You gotta cut threading, you just tape it. Use a zip cutter, like an angle grinder, or just a cutting disc on a Dremel. Fucking focus. The only thing is, give it a second to cool. Before you try to take it off. Otherwise, you end up with brass plated fingertips, because this brass gets really soupy when you cut it. That's definitely gonna leave a mark. I had to drill out those knurl nuts because they were 632, and these spacers are M4. And I cut the heads off of a couple to make little threaded rods. So that they clear those nuts and make little legs. So now, just 4 more of those. So there you can see the pieces that are going to make the false bottom. We got our plexiglass piece all cut to shape with the holes and the countersinks to sort of get this screw sitting in flush, and then the actual legs themselves. See if I can kind of point out what those. They're just really simple, just quick. Each one's made up of a little sort of M4 piece stub of threaded rod, which I just cut the head off a brass M4 screw, and then M4 nut, M4 spacer, 632 brass knurled nut, bored out 5/32 to clear the M4 rods, and then another M4 bolt. And so now we can slap that together. I just angle the camera a bit. But it'll show you anyway. Good enough. So basically all I gotta do is, I don't know if you can see this or not, but you see the countersinks so that the screw heads will sit nice and low, flush on there. So what we're gonna do here is start off by just popping all these screws in there. Ooh, that's gonna be a problem. Well, not a problem at all, but it's tighter than I expected. It's not bad though, that's good. So, just make it all that easier to put together if it's a little more sturdy. Alright, so what's what here? We got front and back, okay. So hopefully you still see that. I think so. So now that those are through, it's just a simple matter of putting the spacers on. Just make sure that I got those nice and tight. Okay, next comes, well, the way to do this is just to take the little piece of threading and just thread it through the nut about 1/8 of an inch. And square to the, takes a little adjusting, just gotta, almost like timing rings, like I just gotta get the threaded rod to a good spot where, get the nuts nice and flush with the hexagonal shape of the other one, so that they line up square, if you know what I'm saying, the nuts to the spacers. Okay, so do that, and then the last step will just be a little bit of epoxy, just the tiniest little dab in the bottom of the knurl nuts, just for the sake of, because those I've bored them out so that this can actually go right in. What's going on here? Did I do one too many? No, tripping. I'm tripping. I was gonna say, frickin' all this brass hardware is not cheap. Well, it is cheap, but cumulatively, it isn't. enough for this fucking cat. Bam. Now a little epoxy in the bottom of those, and it'll be pretty damn smart. I won't need anything but the tiniest little bit. Tiniest little bit of this stuff. Let me double check that these are square and tight. Yeah, see, this fucker wasn't. Beauty. I just had to make sure that those were all sitting square. Alright. Not fucking around. I gotta make sure I don't leave any sitting on the bottom surface of the knurled nuts. Otherwise they won't sit right. This plexiglass piece, it's really it came out to a really nice fit. So it basically is friction fit inside that box. But it will be getting a bead of epoxy. It'll get a bead of epoxy around the edges though, just to make sure that no little cracks or anything like that. Alright. Now I gotta wipe that off with something. Get some acetone handy. Pretty good. So with the epoxy's all a set there, so the false bottom's totally done. It's really nice. You can see how the legs kind of turned out there, and the screw's nice and recessed. You know, nicely sunk down in so they won't interfere. That little chip there bugs me. That was already in. These two countersinks are the ones that were already in. This was a guard on a piece of machinery, right? And at my work, and it was only secured by the bottom. The guys are always leaning on the guards, so you know it cracked there a bit. But the stuff's so strong that's definitely not going to be an issue, because this doesn't hold anything of weight at all. But yeah, so there's those. That'll be pretty nice. That'll go in and be the false bottom so that we can the electronics in. Now for this version of the circuit, it's the same exact circuit as the last ones from that I saw Big Clive do, the light sensing circuit. And basically, let me see if I can get this all in frame. So it's pretty simple. The supply just comes in over here, and then through this, that's a 15K resistor, comes down to the base of this transistor right here, just a typical 2M3904, and that's also spliced in with the LDR over here. And I just have that in this version running off, it's off this white wire here, just because this is going to have to be mounted in the side of the box, obviously. So I can't have it mounted on the PCB here, because the PCB will be down under the false bottom. So then it just comes down, you know, the collector of the transistor is this orange wire that's going out to the LEDs, and then the emitter is down here, which is also common with the negative to the supply. So super easy. That's basically, you know, ready to just drop in. I'm gonna cut that off here, drop that in the bottom, and that will be like the part of the circuit that actually drives the lighting effect. And then here's what we're using for the LEDs on this one. And this is just like a little kit, you know, a little DIY electronics kit, the LED flasher, and this one was in the shape of a heart. It's just really simple. It's just like about 18 LEDs and a few capacitors and transistors and resistors. Now I had mixed thoughts on this, because sitting underneath, if you remember what the case looks like, that's going to sit right underneath the 555 timer chip, and it would look cool still in the heart, but originally, you know, because you'd see that superimposed underneath the chip from the bottom, and it would kind of put the focus right in the center of the focal point of the case, which is kind of cool. But originally, what I thought of doing was splitting this up and basically jumping the LEDs out and spreading out the effect to a larger area, getting more bang for the buck. I still kind of torn, because like, here, let me show you why. Because if you remember the actual circuit that's controlling this over there on the right, everything over here that you see flashing on those LEDs, that's coming through the collector on that transistor, right? And those transistors, if you look it up, they'll tell you in the spec sheets that they're really only rated for a couple hundred, like 200 milliamp. But the thing is, I think if you actually talk to people who know electronics, they'll tell you that really you can put more, like maybe, you know, more than 200 anyway, like half an amp or so. And then, you know, a lot of people, like, basically you can put up to about an amp on there and it's not gonna fail instantaneously, so it's just gonna pop on you, but no more. So, you know, up to an amp it's not gonna fail, but you don't, like, that's a lot more than it's actually rated for, and it's probably not gonna last as long. So basically, the reason why I'm going on about this is because if I put a multimeter to this, let me do this so I'm not blocking anything. Move this box out of the way. So if I check this, sorry, I'm trying to do this so I'm not blocking everything completely. It's tough on that angle. You can see that? It's about 400 milliamp right there. Now, interestingly enough, if I come in and over here instead, I gotta switch these up. Just a little farther right up on the exact same leads. It's weird because it drops a decimal place. But, well, that's a lot less than that even. Isn't that weird? It's just giving me a totally different reading. That's on the exact same leads, just farther up. That's fucked. Um, well, they both can't be right. But it's gotta be the 400 because there's almost 20 LEDs, and from the tracks, you can see that they're all in parallel. They're just grouped in clumps, and some are have capacitors and resistors intervening. But you can see that they're all running around 20 milliamp. So you know, and they're all in parallel. So it's running around half an amp. So basically, if I'm already running half an amp, then I don't really want to be adding a whole bunch more onto into this, because everything's gonna have to be coming through this transistor. So that basically makes the decision for me, because in this case I was trying to decide, do I just put that down inside sorry, under the false bottom, central, so that it still shows underneath that timer chip as that heart itself, and then just add more LED effects underneath here, right? And just to get the amount of effect that I need, because this is a little too small and centralized and it leaves everything else empty, right? It would only have the effect in the middle. Or, so do I put that in as is and then build more onto it? Well, I'm already kind of running about as much as I feel comfortable running through that transistor over there. If I would have had to force it, I could have put another transistor in parallel in the same spot, and it would have given me almost like a second channel, so to speak, to add a whole other set of LED effects in here, right? But as it is, I don't really want to load up too much more through this transistor. So I think that basically makes the decision for me. Instead of leaving this heart intact in the center underneath this chip, under the false bottom here, right, like, instead of doing that, I will basically chop this up and jump these LEDs and spread them out and take away the heart shape and basically move a lot of these LEDs out and around and spread this out so that, this basically becomes the LED driver for this whole box instead of just one little effect inside of it. I know people will probably shake their heads and probably say I could load this right up to an amp. Other people might say, oh, you're already overdriving it. It's rated for 200 milliamp. I figure I'm taking the middle road, right? I don't want to go ahead and put another transistor in over here and try the multiple channels thing, quote, air quotes, channels, because I'm going to save that for another one, just because if I get carried away doing too much at once when shit doesn't work, the troubleshooting process becomes a nightmare. I just want to take it one baby step at a time. So for now, we'll just add, Frankensteining kits into the circuit, and then on the next step, we'll blow it right out. There's plenty. 18 LEDs in a little tiny box like this is plenty to get the effect that I need. So I'll spread these out. And another thing that's interesting about this board, if you notice, is I actually soldered everything in on that upside down. Let me get this out of here. The board, it's the kit. There's the actual board, right? But that looks tacky to me. And you're gonna see this through the bottom. The whole point of this project is that you see the guts. I like the look of the exposed electronics. And I didn't want to be looking at that. So I actually flipped it and soldered everything in upside down, which was like a lot of holding my tongue the right way, because the polarity, it would have been super easy to fry stuff by getting it in wrong, because I actually had to put the components in, the other way since they were flipped. But yeah, this is gonna be quite cool. So let me, we're pretty much there. I just gotta um, split these LEDs out to spread out a little more under there and chop that off and then just pop this in. The box is already fitted for all this stuff, so it's like Lego at this point. I swear I need to start making notes or something, because as soon as I start recording I always forget all the shit I was supposed to actually talk about even. But forgot to say, even just show you how this is going to work. The way that I got this set up is not like this is Big Clive's light sensing circuit, like LED driver over here on the right? And it's the main thing of it is this LDR. Well, instead of just being like a typical on off, like you typically, like, what the thought with this is activating the LEDs when it gets dark. I kind of just basically what I did was I found the perfect balance of resistor values so that it's not really gonna go off. I'll show you, like, it will if you put super bright overhead light right on the LDR. See how even now the LEDs are still on and that light is right on it. It's only until now they're starting to dim, barely on, and off. You probably can't even see that on camera. But see, as I start to get the light away, you'll see they're well on now, just very dim. And they start to get brighter and brighter as it gets darker and darker. I'm angling the light away from the LDR right now. And the more I angle this light, you can see they get brighter and brighter. But then at a certain point, the voltage gets high enough that that circuit there that you're seeing on the LED flasher circuit, it starts to do its thing. And now as it gets darker and darker, the voltage gets higher and higher, and those, the pattern becomes more of a obvious flashing. And the darker that it gets, see if I can do this without covering up your view of it. The darker that it gets, it starts to the LEDs get brighter still, obviously, but it turns to more of like it's faster and faster of a flashing, and to the point where it actually becomes like a shimmer instead of a flash. And basically, so the whole idea with this, I'm gonna keep messing with the light levels here, so you can see, is that it's just basically it's never gonna shut off. It just changes with the light level. So it's not so much that it's going to be going on or off depending how bright it gets, so much as it's just a dynamic LED, pattern. Like, see how now that the light's getting brighter, it's not so much dimming out, it's just changing the pattern. It's getting faster and faster and faster of a flash until it actually lights solid, and then only then does it start to dim out. So that's the idea with this, is that instead of just being like, oh, coming on when it's dark, it's pretty much always going to be on. It's just going to, as you walk by, and as the breeze blows the curtains a little bit on the window and more lights come in, this thing will just be sitting there on my little side bench, just constantly, changing. And so that's the idea here. So I trimmed the module so that it can be mounted in the box, and just because when that got screwed in, it's not focusing. When that gets screwed in, the joins there on the back, I don't want them to get pressed on when they get screwed to the inside of the box. So I made a little spacer out of a scrap piece of the plexiglass, and it just has indents, and it just cups around this. So I'll see if I can show you how this lines up. So it just provides a gap so that those connections aren't being pressed on when this gets screwed to the box. So now I'll be able to mount that really well. So that's how that will mount. Just so that way it can be super secure and tight, but yet not be putting pressure on the backs of those joins. So that worked out pretty slick. That's pretty much a wrap. So there you can see there's the LDR going in the little control module, the legs, the false bottom. Turned out quite nice. Still have to put up sticker up the outside a bit more, but you can see the LDR kind of where that sits, just in the bottom corner there. Kind of give you an idea of the different ways it looks depending on the light. Does a lot of different yeah, pretty slick. It's got a pretty decent power cord on it. It's got a good length of it. So yeah, like it's got you can see there, it's got a pretty good length of cord, and yeah, pretty slick. Just get my junk back in here, make sure these wires clear, and like I said, it still needs some more stickers and whatnot. But that's pretty slick. I mean, you can see like Arlo's messing with the blinds, right? And like even just a little bit of, you know, the waving curtain and the little by the breeze or by the dog or whatnot is enough that it's gonna constantly affect how that goes. You know, so like any little bit of motion or something in front of it and it changes. Pretty cool. That's gonna be pretty slick. Yeah, anyway, that's a wrap. Thanks for checking it out, guys. I'm pretty happy with that thing. Turned out slick. No on switch or anything. It's just gonna be, you know, it naturally has an on switch if it gets too bright.